Hello everybody. Tim wanted me to do a quick video on this nanoVNA. VNA stands for Vector Network Analyzer, and it gives you so much information above and beyond just a simple SWR reading on your coax and on your antenna. Matter of fact, this thing does so many functions that I'm only beginning to scratch the surface. It's a very small unit, that's hence the name Nano, and this is actually the smallest model within that series. You can see there's a US penny just in size comparison, very tiny screen. If I bought one again, I would probably go with the next bigger size, which would give you a 4-inch diagonal screen, which would be a little bit nicer. However, you can patch this into your laptop and with a downloaded program, see the display on your laptop. I haven't done that yet, but that would definitely be handy. So one of the first things you need to do every time you use it is standardize it or calibrate it. So it comes with calibration standards, these little guys right here, that you calibrate an open, a short, and a load, which is a 50 impedance or 50 ohm impedance load. And once you have it set, you can save that calibration. So theoretically, you want to do it every time, but you really don't have to because once you save those calibrations, if you remember how you saved them or where you saved them, you should be good to go. The next thing, you determine what you want to test for. So for this case, I'm just going to click on display here and look at the traces. And I can see I've got 3 traces set up out of a possible 4, and each one is set up to do something different. So trace number 0 on here, it's got the check mark next to it. That is actually set up to display log mag. So that's going to show me the log mag of whatever I'm testing. If I go back and check out trace number 2 by highlighting it like that and hit format, that is set up to show me the Smith chart of whatever I'm having to test, whatever antenna or whatever I've got hooked up. And then finally on trace number 3, actually it's trace 2 on the screen, but it's the third one I have set up, that is going to show me the SWR as checkmarked right there. So that's what we're really kind of familiar with. And you can set up too, it's the range or the scale when you want to do some testing. So I don't need to scan the whole frequency band. I don't know, this goes from 0 to 900 or megahertz, I think, or something. I don't even remember. But I don't need to do that whole thing. So if I click on stimulus here and start frequency, I can set it up to do whatever frequency range I want. I'm going to do 440 megahertz as the start. And then as the stop, I want to go to 480, and that should give me a good view of the range that I want to look at. So now I'm just going to connect the SMA connector to my little Yagi antenna here that I built to the 1 port, or S11. And as I get that firmed up, you'll see the screen totally change. Now, if you look at the number here, hope maybe you can see this on the video, 466.800. That's the frequency that the analyzer is positioning these markers at. So if I go up to 467, where we would normally be transmitting on for our repeater frequencies, there's 467,600, 467,600 as close as I can get. That's one of the downsides to this. It only has 101 points, data points. So if you want to get finer detail than that, this probably isn't the unit for you. But where the markers are right now, I'm at 467.600 and my impedance is 48.7, so it's right there near the center of the Smith chart. Perfect would be 50 ohms. My log mag is minus 14, not bad, and my SWR here, the green numbers, 1.49, 1.5, bouncing back and forth. Now as I change, I can drag these markers around and get to different frequencies. I'll go down to 462, right there. I'll go down a little bit more. 462,800, you can see how the numbers have changed. Now my SWR is up to 1.7. On the Smith chart, I'm up to 83 ohms of impedance, and the log mag is now minus 11. So again, I'll go back to where we're going to be transmitting. And that's how you tune the antenna, actually. And what I'll do now is I'll get it back to 467,600. And I'm just, you can't see it, but it's going to be off camera, but I'm just going to touch the radiating element on this little Yagi that I have it hooked up to and watch what it does to the chart. It's going to totally monkey it up. So you can see how much that just throws that antenna way out of whack just by making contact with that radiating element. So now to tune this antenna, what I would do is just slowly snip away at the radiating element, if that's the direction I need to go anyways, and just watch the results on the nanoVNA. Another cool use for this thing that I found is pretty cool is just to test a length or any defect in a piece of coax. So my coax running up to my antenna, I know it's 65 feet long, but if I didn't know the distance of the coax or the length, I could measure that. And if I had any faults, like a nick in the coax or some damage or whatever, it'll show up on this nanoVNA under a different set of testing protocol. But pretty cool tool. In this particular one, with the testing standards, with the couple little patch cables and the charger and all that stuff, under $50. Now, you're only spending $50. You can't expect to get the type of results that you would from a professionally designed and engineered, benchtop analyzer. But just for the hobbyist like I am, I mean, it really is a great little tool. I hope this video helps. And if you have any more questions, send them to me on Tim's Telegram page, and maybe we can talk about it. Take care.